Hey everyone, so we're going to be talking about simulating an epidemic so we can see how infectious diseases are spread in communities. When we look at these models, they break up the population into three groups: susceptible, infectious, and recovered. Um, and you'll see these as these symbols in the simulator. Susceptible means I'm going to be using the video on the left as well as the note section here on the right. Feel free to pause the video at any point so that you can get the notes down in your notebook. It's crucial that you are maintaining these high school ready habits um, so that you are prepared for freshman year. Because regardless of the fact that we're distance learning right now, um, freshman year will happen, and we want to make sure you are as ready as possible. And so, three groups: susceptible, infectious, and recovered. Um, Sometimes they actually also, instead of using the term recovered here for this group, they'll also call it removed. Um, Susceptible just means that you can be infected. Um, Infectious means you have the infection currently, and then recovered means that you had the infection and you've come out of it. They also call this removed because sometimes people do die from the infection, and so we would not qualify that as recovered. Now you see these circles here. That circle is the infection radius, which is basically like your little bubble of how you can spread the disease if you have it, as you are walking around, going to grocery stores, schools, etc. So this is where the idea of like social distancing came from. Okay, we're going to let this play through. So what you're going to see here, you're going to see some graphs on the left, and you will see some moving pieces on the right. All right. Here's the first model. As you can see, this is basically the city, which is obviously fake. None of this data is based on real pandemics or epidemics. This is just a simulated model. So as you can see, the blue dots are just the susceptible population, which means they are currently healthy, but they have the ability to get sick. And when we let this run, so everyone's just going to be walking around randomly. And as you can see, the infection is spreading. It starts to pick up. The number of susceptible is dwindling. The number of removed is increasing because people are getting sick. And after some time, the majority of the population has gotten sick, or is currently infected. And the amount of people who are not sick or who have never been sick starts to go down. So if you look at your notes here, the first run, everyone was moving around the city. The result was eventually, over time, everyone gets infected. Now, if everyone is moving around the city, that means that city is not taking any steps to slow that spread. Okay. The second run that we're going to see here, the change that they're making to this simulator is they are making the infection more infectious. What that means is they're increasing the radius of infection to include more people. Now, in a simulated model, that just means that the closer you are to someone who is infected, so these little guys here, their chances of getting sick are now greater because they are inside the radius. But in the real world, what that could actually connect to is just socializing without any concern, not washing hands, touching face without washing hands. So those things can make an infection worse because it makes it easier for you to get the infection if you're out more, right? Someone who is constantly going out and about with other people would have higher chances of getting sick than someone who didn't, okay? So that's the connection here. So we're going to look at the result of if we make this specific infection more infectious. As you can see, it's starting to spread faster, but you'll notice right here how it just peaks, right? So at this point, this is, if a city knows that there is an infection happening, or a town or whatever, a community, this scenario occurs when the city or community does nothing. Just kind of goes about business as usual with everyone running around the city and not taking any steps to reduce the infection. Now, this becomes a concern because when the infections get this high, that means there's like almost everyone is sick at the same time, and this is the concern with like overwhelming the hospitals. Because if this were to happen, there might be too many people who are sick than the hospitals can handle. And this is why in Illinois, as we are dealing with COVID-19, this was the whole push of like, let's lower the curve. This is the curve they're talking about, because if we can get this lower, like down here, then we can keep things in the hospitals less tight, okay? So we'll just let this continue to run through. As you can see while this is running, just looking at the notes, we see a drastic speed of infection increase, okay? And another note that we could add here is that we, like this situation has the potential to overwhelm, spelled that wrong. If you guys haven't figured this out, if you're using Word, if you right click on the word, it can correct it for you. Has the potential to overwhelm the hospital system or healthcare system. Now, the next run is this person lowered the infection probability, which means the chances of you getting sick are now lower in the simulator. In the real world, that could connect to like constantly washing your hands, less contact with other people, and then also like less face touching. And then let's see the result here. So there is an infection happening. It is starting to spread somewhat, but just notice already, like, we can tell that the curve of this infection is way lower. There are way more people who are not sick currently. And as you can see, this has gone on the same amount of time as the other ones, but this curve did not get that high. And so that, that has a drastic reduction in the speed of the overall infections, which really saves the hospital situation here.